A telephone pole has a wire attached to its top that is anchored to the ground. The distance from the bottom of the pole to the anchor point is 28 feet, less than the height of the pole. If the wire is to be 4 feet longer than the height of the pole, what is the height of the pole? Okay, this is when I'm going to read the problem a second time. I haven't done that on every one of these just to save time in these videos, but let's think about it and look at the picture. A telephone pole has a wire attached to its top that's anchored to the ground. That's what they're talking about right there. The distance from the bottom of the pole to the anchor point is 28 feet less than the height of the pole. That's this distance here. If the wire is to be 4 feet longer than the height of the pole, what is the height of the pole? And here's the height of the pole. Our very first step is to define our variables. So h is going to be height of pole. So in this picture, that's h. It tells me the wire has to be 4 feet longer than the height of the pole. So this measurement here is going to be h plus 4. And the distance from the bottom of the pole to the anchor point is 28 feet less than the height of the pole. So this distance here is h minus 28. So we have a right triangle. This is our right angle. This side is h minus 28. This side is h plus 4. And this side is h. So we're going to use the Pythagorean theorem. And that's going to give me h squared plus h minus 28 squared equals h plus 4 squared. I've copied that over here, and we're going to expand these two pieces, the h minus 28 squared. We're also going to expand the h plus 4 squared on the other side. So on the left, we're going to have h squared plus h squared minus 28h minus 28h plus 784. On the right, we'll have h squared plus 4h plus 4h plus 16. So collecting like terms, I have 2h squared minus 56h plus 784 on the left. And on the right, I have h squared plus 8h plus 16. Now I'm going to subtract everything that's on the right and move it over to the left. That's going to leave me with h squared minus 64h plus 768 equals 0. And these two things are going to factor into h minus 16 and h minus 48. So you're just trying products, two things that multiply together to give you 768, and when you add them together give you negative 64. And when it's big like this, I got kind of lucky and I hit it on the first one. So now I'll transfer that to another page, and I'm going to set each linear factor equal to 0 and solve. So h minus 16 equal to 0, adding 16 to both sides gives me h equals 16. H minus 48 equals 0, adding 48 to both sides gives me h equals 48. So those are my options. I went ahead and transferred this picture back over here so we can see what happens, because we've got to figure out which of these choices makes the most sense. So if I know that my h is 16, if I look at those dimensions, I will end up with h is equal to 16. H minus 28 is going to equal 16 minus 28, which isn't looking good because this is going to give me a negative number. That's going to give me negative 12. So I'm done. I'm throwing out h equals 16 because I cannot end up with a negative dimension on one side of my triangle. So essentially then my solution for my height is going to be h equals 48. So my height is 48 feet.